Hello everyone, my name is Siddharth and I'm a master student at UBC. Today I would be talking about an interesting topic called thermodynamics. In this video, I would be briefly describing certain important topics in thermodynamics, and at the end we would be solving a question. The topics that I am going to cover in this video are: what is thermodynamics, why study it, what are fundamental laws of thermodynamics, what are different forms of energy, how to define system boundaries and surroundings. Before I start my presentation regarding thermodynamics, I would like to ask you some interesting questions. Have you ever wondered why it is so tough to keep your house cold on a warm sunny day? Or have you ever wondered why it is so difficult to keep your house warm on a chilly winter day? So, what is the reason behind it? Well, let's find out. Before we find out some answers to these questions, let's understand what is thermodynamics. Thermodynamics is defined as the science of energy. It comes from a Greek word called therm, Therm means heat and dynamis means power. Power can also be defined as something moving. So heat in motion is known as thermodynamics. Anything that involves energy could be studied using thermodynamics. The second question that comes to our mind is, why study this concept called thermodynamics? If you look at this picture carefully, all the things shown in this picture works on the principles of thermodynamics. You must be thinking why a human being is shown in the fifth image. In fact, human beings are also working on the concepts of thermodynamics. In the industry, in any industry you go, there is an involvement of energy. And whenever energy is involved, uh, we can study the flow of that energy using thermodynamics. Moving ahead, what is energy? Have you ever seen it? We many a times we say that when a person is active, he has more energy. Or in general layman terms, we say that the car's energy is determined by the amount of fuel it is carrying. But can you ever see this form of energy? Well, the answer is no. And how to define this energy? Energy is anything that has the ability to bring about a change. And we use certain fundamental laws of thermodynamics to quantify this energy. So, if energy can't be seen, can it be measured just like temperature? We measure temperature by thermometer. Can it be measured just like pressure? We measure pressure by barometer. So, there are certain instruments to measure certain parameters that are important to us. But in a similar way, can we just have an instrument to measure the energy of a body? Well, the answer is no. Therefore, we require these fundamental laws to come up with certain uh, equations that can help us calculate the energy of a body. We can only calculate the change in the energy of a system. And how do we do that? We'll learn further. So first of all, let's look at the units of energy. Units of energy is joule. So whenever we calculate energy, we calculate in terms of joules, which is the standard unit of energy. Now let's look at some of the laws of thermodynamics. The first law of thermodynamics is related to conservation of energy, which states that energy is a thermodynamic property which can never be created nor destroyed. You must be wondering what do you mean by created or destroyed, and what does it mean that energy can't be created or destroyed? Well, energy is a thermodynamic property that can only be converted from one form to another. Let's take an example of a cup of tea. So, when you keep a cup of tea, a hot cup of tea on a table, it slowly loses its energy, and the heat that it loses goes into the environment. If you talk about a ball falling from a height, the potential of energy of the ball gets converted into the kinetic energy as it falls down from an height. If we talk about a moving car, the energy produced by the fuel gets converted into the kinetic energy. So it's always the conversion of the energy. Energy can never be created nor destroyed. The second question that comes to our mind, if energy is always conserved, why are we talking about, or why we are concerned about conservation of energy? Why we always want to conserve energy? There are many a times you must have heard that you shouldn't leave your lights open because that leads to wastage of energy. If energy cannot be destroyed, how come it be wasted? There comes the second law of thermodynamics, which talks about the quality and quantity of the energy. So it says that energy has quality as well. A higher quality of energy can be converted into useful work, but as the energy degrades into lower forms, it cannot be converted into work. And what does higher grade energy means? A higher grade energy means energy at a higher temperature through which we can obtain useful work. We would be studying these laws further in detail in another video. Here we are just looking at the introduction. Moving ahead, what are different forms of energy? So I already discussed some forms like kinetic energy, potential energy. Let's look at this question. If we have a cup of coffee, what possible forms of energy can it have? Let's try to figure out what forms of energy can it have. A cup of coffee can have heat energy because it is hot. It can have some maybe a chemical energy because it has some liquid in it, which can produce some heat again. Now let's look at what are different forms of energy that we have. Energy can be subdivided into two parts or two categories. First is the macroscopic energy, or we call this as mechanical energy sometimes. Now, what is mechanical energy? Any type of energy that can be directly converted into work comes under this form of energy. It has two categories, mainly two categories. One is kinetic energy, which is energy due to the motion of a body, and the second is the potential energy, which is the energy due to uh, the height at which it is from the ground level. So these two types of energy comes under macroscopic energy. Now let's talk about microscopic energy. Microscopic energy is the energy that a body has which cannot be directly converted into work, but requires certain type of process. For example, you must have seen the burning of coal. Coal in itself has this internal energy which can be converted into heat later on. So this type of energy comes under internal energy, which is due to the motion of the molecules, which is due to the vibration of the molecules, or which is due to the certain way in which the molecules of a body are arranged. Under internal energy, we have chemical energy. We Another type of energy that comes under internal energy is energy due to high temperature, and also the energy due to the motion of the molecules in a substance comes under internal energy. Internal energy is very tough to imagine as compared to potential and kinetic energy because this type of energy we cannot see directly. Although this is process, it has a very important role to play, specifically in chemistry and chemical engineering uh, subjects. Now let's look at the last topic of this video, that is system boundaries and surroundings. In order to study any type of system, we define certain boundaries. So is a system is a defined area that we are studying right now. So in order to reduce the confusion, we make a boundary around the system which is under our study. For example, let's say I want to know the energy possessed by this mobile phone. So for me, this mobile phone would be my system, and I would be drawing a boundary around it. Anything outside this boundary is called as surrounding. Now, there are many types of system. The first system is an isolated system. What does an isolated system means? And in an isolated system, no mass can come in, neither can energy enter this system. So both mass and energy cannot transfer through the boundary of this system, which is isolated. The second system that we talk about is a closed system. In a closed system, the mass cannot enter the boundary, but the heat can enter it. Heat can be transferred through this boundary. In other words, you can consider the boundary of this system to be porous, through which only energy can be transferred. The third system is an open system, where both mass and energy can be transferred through the boundaries of the system. So that was all related to the basic concepts of thermodynamics. Now, moving ahead, we would be solving a simple question related to uh, energy. So the example that we are going to solve is a school is paying $0.12 per kilowatt hour for electric power. To reduce its bill, the school installs a wind turbine with a rated power of 30 kilowatt. If the turbine operates 22 hours per year at a rated power, determine the amount of electric power generated by the wind turbine and the money saved by the school per year. So what is being told in this question? There is a school that currently is working on the power that is coming from the grid. Grid is the source of power for this school. The school is now deciding to remove the connections from the grid and start getting the power from the windmill. And the question is, if tomorrow this windmill is installed, how much amount of money the school can save per year? So first of all, we need to find out how much total energy the school is uh, currently getting. So we know how much hours per year the electric power is being coming to the school, and we know the power as well. So the total energy that is being required by the school can be given by energy per unit time into time interval. In our question, the power rated power is 30 kilowatt. So we have 30 kilowatt here, and the time interval is 2200 hours, which gives us the total energy of 66,000. Moving ahead, we now need to find out how much savings we would be making in terms of dollars if we are able to bring this amount of power through a windmill. Let's look at the equations we have. The money that we would be saving if we bring 66,000 kilowatt hours from the windmill is total is given by total energy into unit cost of energy. So unit cost of energy in our question is $0.12, and the total energy that we would be saving is 66,000. When we multiply these two terms, we get the amount saved that is equal to 7,920. So that's all for today's video, guys, and I would be ending this video here. Thanks.